Welcome to the video key for the stoichiometry take-home test. If you were absent for your classes in class review, please take a look at the very last page. Okay, we did a lot of these as stations for the students in class. So for the first question, there's the word bank. Okay, for question 13 and for question 23. The material you need is on the last page of this. Alright, so using the word bank on the back, I want to take a look at some of that vocabulary. Okay, so we gave you a lot of these terms. I especially want to look at these ones in purple right here though. Okay, so it says the percent yield shows the blank of a reaction. Alright, and we're looking for the word efficiency. It's how efficient your reaction is. So if your percent yield is close to like 60, 75, you did not have a very efficient reaction. You could have been a lot better, closer to 98, 99%. And you find percent yield by dividing the blank yield by the theoretical yield. That would be the actual yield. Right. Writing formulas and naming compounds. We learned this back in Unit 3 this year. It's still stuff that you're responsible for knowing. So remember, we're talking about 4-step formulas here. So for barium nitrate, the first step is to get the symbols. So the symbol for barium and the symbol for nitrate. And nitrate isn't nitrogen. It's here on this list. Nitrate is NO3, making a -1 charge. Okay? So that's both symbols, one of my charges. I need both symbols, both charges. So we need to find barium, and we see that it's a messy metal with 2 valence electrons. So barium will react to lose both of those valence electrons. Then we need to crisscross. This one comes here, that 2 goes there. And then reduce and erase. So our final answer should be a invisible one, NO3, 2, like that, barium nitrate. Alright, I wanted to look at some of the naming ones as well. Remember, if it's ionic, if you have a metal, like all 4 of these have metals in it, then you have to check for Roman numerals. So MgCl2 and MgClO3, 2, we need to check magnesium. And since magnesium is one of the A families, it does not get a Roman numeral. So I just call this magnesium. And then no Roman numeral. Chlorine, we change to chloride. Magnesium chloride. Magnesium, and then I see that there's a polyatomic ion there. So we look for ClO3, which is right there, chlor8. So that's what we call it. Chlor8. And then remember, we said almost right is wrong. Almost right is wrong. So we need to make sure we're being careful with those endings. Number 1 says, which of the following metals require a Roman numeral when naming? Lithium, aluminum, nickel, silver. So here's your first opportunity to get some extra credits. Put +2 and then EC for extra credit. If you write, okay, metals are messy. That's our first little code. Metals are messy. All 4 of these are metals. They're going to lose valence electrons. So we'd say lithium is in an A family. It does not get a Roman numeral. So I'm going to take out the garbage and say lithium doesn't need one. Aluminum is in the exception block, so it does not get a Roman numeral. Nickel. Nickel is not in an A family or the exception block, so that looks like the right answer. And then I check silver and see that silver is in that exception block. So I can come back and grab this. Alright, number 2. What is the name of the following compound? Now, technically, this is the correct way to write this. You'll notice that we left the parentheses off for this problem, and that's okay. We're trying to wean you off of always seeing them with that. But I'm going to find rubidium, and CO3 right here on your polyatomic ion list is carbonate. So not cobalt, not chlorate, not carbide, but carbonate. Okay, don't get thrown off by the missing parentheses there. That's okay. All right. If you need to check any other answers on this page, feel free to pause it. Otherwise, let's go to page 2. All right. On page 2, starting up here at the top, you're given this reaction. Methanol plus oxygen reacts to form carbon dioxide and water, which shows you that this is going to be a combustion reaction because it's CH and O. Okay? We're giving you the chemical formulas for methanol, oxygen, carbon dioxide, and water. And then it's asking you to find the molar mass. I gave you these two. For this one, you're going to have to add them up. 1 carbon plus those 3 hydrogens, plus that oxygen, plus that other hydrogen back there. There's actually a total of 4. And then for this one, it's asking you for number of moles. This is something that students still seem to get confused on. That means the coefficients. So we're asking you that 2 of these react with 3 oxygens to produce 2 moles of carbon dioxide and 4 moles of water. Okay. So that's all it's asking you about number of moles. What are the reactants and what are the products? So your final product, okay, your final products are the stuff over here at the end. So that's going to be your next chance for extra credit. Go ahead and write that and put plus 2 EC for extra credit. Oops, excuse me. Plus 2 extra credit. So your products, of course, then would be whatever's at the end. So CO2 and H2O for this problem. And that puts our reactants as what's the beginning of the reaction. So methanol, which is CH3OH, and oxygen, O2. Your reactants and your products. All right, make sure you're finishing up the rest of this table on your own. Okay. You did number 7 as a lab station, so I'm not going to work on that with you right now, but I would like to look at number 9. Okay. Number 9, oh my gracious, people, box in your givens and circle your unknowns. Cannot tell you how much of the problems people are having in homework is because they're not boxing and circling. So I see a number, 5 grams of methanol. So that is my given number, unit, and compound. And I see another one, 5 grams of oxygen. So I'm going to box that in. It's asking me how many moles of water will be produced. So I boxed in 2 givens, and I'm circling 1 unknown, which tells me this is going to be a limiting reactant problem, which means we need to do it twice. All right, you will be allowed to have your foldable on the test. So for this one, I see that my given is grams, so I want to open this side up so that shows that I'm starting in grams. And because I circled my unknown, I see that I'm supposed to stop in moles, which means I need the second side to stay closed, so that this would be a 1-2 step problem like this. Okay, so I'm going to give myself that double T chart for both of my givens, like this. Okay. All right, then I have 5 grams of methanol, which if we look way up here, there's this guy right there. So, well, right here you can see it too. CH3OH is my first given, and my second given is 5 grams of oxygen, which you need to be very, very, very careful. They remind you here that it's diatomic, so the subscript matters, O2. Okay. So using the foldable, it says to just go down grams of the given compound. Grams CH3OH, and it tells me to put 1 mole of that on top. 1 mole of methanol, CH3OH. Okay. Then I just go everything but the number down and say blank moles, CH3OH. And now that I have mole on bottom, I can put mole on top and change chemicals. So the unknown compound they want me to solve for is water, H2O. Okay, and I know to stop there because I circled moles of water, and I stop when what I'm looking for is on top. All right, it tells me to get the molar mass. in front of the bottom one, which let me grab my answer key so I can show you all that. Okay, so the molar mass of methanol is 32.042, and then it tells me to put the coefficients here. So the coefficient for water was right there, 4, and the coefficient for methanol is right there, 2. Alright, now I'm going to multiply everything across the top and divide the rest. So 5 times 1 times 4 divided by 32.042 divided by 2, like this. And I get 0.312. 0.312. That is not my answer, not yet, until I solve this next one. Okay? So I'm going to stick this up here so we can see it again. I disco down my units, grams O2. Because I have grams on bottom, I'm stuck in O2, but I can make it mole O2. And your foldable even reminds you that on top right now we should have 1 mole O2. And then I disco down everything except for the number, mole O2, and now I can change chemicals. And we're changing to water in this case as well. Okay, so 1 mole goes over the molar mass, and the molar mass for O2 is 31.998. And then we need to look up here for the coefficients. Excuse me. 4 for water again, and then 3 for oxygen. So we multiply everything across the top. 5 times 1 times 4 divided by the bottom, 0.208. Okay. So in class we learned that your smaller answer is your answer. So as I'm making moles of water, we're going to have to stop when we get to 0.208 moles of water. We have to stop at that number because we're going to run out of that reactant, O2. Now, I could make another like 50% because I have enough methanol to make more. So that's my excess reactant. CH3OH, like that. Now what's making me crazy, at least with my students in my class, is people are putting one of these two things as limiting reactant. Those are products. So those cannot be the limiting reactants. My choice is really this one or this one for limiting reactants. Alright, let's look at number 10. For number 10, it says, using the diagram below, how many grams of zinc were produced in this reaction? Now, I've had lots of students, when we got to this question on the homework, just finding me the molar mass. They're saying like 65.38. This was law of conservation of mass that we learned last semester. So we said matter can't be created or destroyed. The total mass before, so in this case 50 plus 150, 200 grams, has to be equal to the total mass after. So right now it's 125 plus blank. Okay, so I'm combining like terms, and then if we're solving for x, I'm going to subtract 200 minus 125 equals 75. So only if we're producing 75 grams of zinc will both sides equal each other. All right, let's go ahead and go to page 3, please. For page 3, I showed you these first two answers. A mole ratio just means coefficients. I feel like a lot of people have been forgetting this. Now we did number 12 and number 13 as part of a lab station, so I'm not going to show you the work because you should have done it with your group. So you have to show work right now if you haven't, but your answer should have been 136.192 grams of NH3. If that's not what you got in your answer, make sure you're coming back and looking at this. And then for number 13, again, it was a lab station. It's on the last page of this handout. If you were absent, okay, you need to write a what's my error. Okay. Question 14 says if 20 grams of NH3, which I'm going to box in, was produced, so that happened in an experiment, and the stoichiometry calculation, which is just theoretical, said we were supposed to yield 29.2 grams. What is the percent yield? So we are not using a stoichiometry foldable for this. That's not what they're asking. The equation for percent yield is on the bottom of your periodic table right here. So it's the actual yield divided by the theoretical. So this is what was produced. We actually created 20.4 grams. We're going to divide by what was supposed to be, theoretically, 29.2, and then we multiply that by 100 to get our answer. So 20.4 grams divided by 29.2 grams, 0.698, and you have to say times 100, so it becomes a percentage. So 69.86, okay, I'm going to say 69.9%, rounding to that. Okay, this would not be considered an efficient reaction. If you only produce 70%, there was a significant error in your lab procedures. All right, looking at this, it says to use this diagram for questions 15 through 17. I'm not a huge fan of these diagrams. They're a reality in chemistry, but it's kind of funky. What we see is A2, right? You can call it this. I have two A's stuck together, and there are 1, 2, 3, 4, 5, 6 of them, plus B2. There's two B's stuck together, and I have 2 of those. And then after the reaction, I have 4 of A3B, okay? Because we said the big ones right here are B. So when we look at this, it's not just A plus B. I'm going to take out the garbage, okay? It's not just A2 plus B2. It's how many of them are there, okay? So you can kind of see when we take out the garbage, it's not an A stuck to a B, it's 3 A's stuck to a B. All right? So that is something I'm going to have you write for extra credit. Plus 2 extra credit. Please write, take out the garbage. Okay, so that's our third extra credit code. Take out the garbage, find the wrong answers, and that helps you find your perfect right answer. This balanced reaction, number 16, is a good representation of the law of conservation of. All of these things are conserved. These are part of our universe. We do conserve energy, momentum, charge, and mass. However, this specific example is talking about conservation of mass. It didn't talk about how much energy they have. This diagram doesn't represent momentum. You don't see positives or negatives. So you're able to kind of go through and get rid of. And then what type of reaction is being shown here? Okay. Decomposition, single replacement, or double replacement. Now it might be harder to tell from the pictures, but if you look at your answer to number 15, you see A2 plus B2 is making one thing. So we're combining two different elements. So we would call this not replacements, it's not breaking apart, so synthesis, it's building up. All right, let's go on to page 4. Let's see what we've got. Okay, so here we are at this lab station. Okay, so probably you finished this in class. Hopefully you finished this one in class. So let's look with number 19 together then. Please box in your givens and circle your unknowns. I feel like I'm talking to a wall sometimes. No one's listening. Number, unit, compound. Box that in, and it's asking you how many moles of water are formed. This is where I am. This is where I'm going. So that's the only way to use the foldable for stoichiometry, is you have to know where you are and where you're going. So I am in moles right now. That's my given. I'm not in grams, so I don't want that side opened. I want to keep this closed, and it tells me to stop in moles. So I want both sides closed. I have a lot of students that are just doing it as hard as it can be, 3 steps all the time, because they're not boxing and circling. And it is breaking my heart and making me sick. Okay. So using this foldable then, and I need to move this so you can see the equation. There we go. This balanced equation for 18, 19, and 20, it says. And I know from my foldable that this is going to be a one-step problem. I put my given, 40.0 moles of H2. I disco down everything but the number. So moles of H2 comes down. And then I can check where I'm at. It tells me blank moles of the given on bottom, got it, and it tells me what should go on top right here, blank moles of the unknown. So as soon as we have moles on bottom, we put moles on top, and I can change to water, H2O. Now, I know mole over mole always gets the coefficient. My foldable also knows that. It says put the coefficient there. Thank you, foldable. So the coefficient for H2O is 2. The coefficient for H2 is also 2. So 40 times 2 is 80, divided by 2 is 40 moles of H2O. Just like that. Good deal. Okay, percent yield calculation. Hopefully number 20 is not too bad for you. Okay. For limiting reactant on number 21, I'm going to ask you to do this one on your own, but I want you to be able to check that you should get iron as your limiting reactant and oxygen as your excess reactant. So you're going to need to show both setups of your work on this one. Okay. And then number 22. Let's look at 22 together. So it says if you start with 6.5 grams of iron, there is my given. It's asking me how many moles of iron 3 oxide are produced, Fe2O3. So now that I've decided where I am and where I'm going, I can use the foldable. And I am not able to get that up on the same screen, so I'll have to put my foldable here. Okay. I'm not starting in moles, so that means I want this side open. And I am ending in moles, so I want this side to stay closed. So I see a double T-chart like this. Okay. And I'm going to go ahead and get my framework out. Then whatever you boxed in goes in this first box. 6.5 grams of iron. And I'm going to disco down grams of iron. And sure enough, that matches what my foldable tells me, that I should have blank grams of the given here. I have to get to moles. So if you don't start in moles, you have to get to moles. And it even reminds me on my foldable to put 1 mole of Fe on top. Then I can disco down moles of Fe. And once you have moles on bottom, you can put moles on top. And now we're able to change chemicals. Okay. So where it says grams, you need the molar mass, which for iron is right there, 55.845. I'm going to switch colors so we can see that. And then mole over mole gets the coefficients. So we look at the balanced equation, and in front of Fe2O3 on top I need to put the 2. In front of iron I need to put the 4, like that. Okay. So 6.5 times 1 times 2 divided by 55.845 divided by 4. You should get 0.058. And then your units are going to be right there. Moles Fe2O3. Alright, let's go to our last page. For the last page, okay, this is on, oops, excuse me, this one's right here. It's on the last page, it was on the lab table for us, but it's asking you this question. So going from 170 grams of iron 3 oxide to grams or mass of iron. And then this is what I showed you for my work. Okay? And your job was to spot the teacher's error. And the teacher's error is right here. The iron 3 oxide is Fe2O3. Okay? And it says that right here, Fe2O3. So that means the teacher used the wrong molar mass. That number shouldn't be 71.844. It should be 2 irons plus 3 oxygens. Okay. So once you fix this number, you're going to explain what the teacher did wrong, show the correct work, and then put the correct answer there. Balancing. I have had so many people worried about balancing, which is fine. Like, if you need to be worried about it, that's great. I showed the work right here for number 28. If you need to pause it and take a look at that. I will also put this one as the last 2 points of extra credit. Hey, look up rainbow balancing. Okay, on our YouTube channel. So the ORHS home, which is me, Kim. Okay, if you search for the rainbow balancing video, if you're still struggling with balancing, this can be really helpful. Because this method of writing it all out is kind of that ping pong method. That's what I'm going to show you up above. But some of you might prefer this rainbow balancing if you're still struggling. All right? So let's look. How I like to do this is by cutting it in half and writing down what I have. So I have 1 Y and I have 2 BRs right now. On my reactant half, on the product half, I have 1 Y and 3 BRs. And then I start from the top and work my way down. So my Y's are balanced. I come down here and I need to get my smaller side to match my bigger side. So what can I multiply 2 by so that it equals 3? And the answer is 1.5 if you want to do that. But really what we need to do is change them both so that they equal 6. The only way to get a 2 to match a 3 is by multiplying them together. So I'm going to put a 3 here, because now I have 2 times 3, 6 bromine. And I'm going to put a 2 here, because now I have 3 times 2, 6 bromine. But that also changes my yttrium. Now I have 2 of those. So I would ping pong to the smaller side and say, multiply this one by 2 so it matches. So your final answer should be 2 to 3, 2. Okay. For number 26, I've got hydrogen, chlorine, calcium, and hydroxide. Now I want to keep OH together inside the parentheses. It makes my life much easier. And I'm going to write it down in the same order over here. Hydrogen, chlorine, calcium, and hydroxide. Like that. Okay. And I've got 1 of everything on the reactant side except for OH2. I've got 2 of those. And then I've got 1 of everything on this side except for chlorine. I've got 2 of those. Okay. So my hydrogens are balanced. I can leave them alone. My chlorines aren't. So I need to multiply this by something so it matches the bigger side, which is 2. By multiplying my chlorine by 2, I also multiplied my hydrogen by 2, which is frustrating, but okay. So even though hydrogen was balanced, it's not anymore. So I'm going to come back up to the top. And I need to multiply this hydrogen by 2. So that gets me double hydrogen, but it also gets me double hydroxide. Alright, so now I have 2 hydrogens before and after, 2 chlorines before and after, 1 calcium before and after, and 2 hydrogens before and after. So that would be invisible ones, 2 to 1 to 1 to 2 the ratio. Okay. If you feel, like I said, if you feel like you need more help with balancing, please look up the rainbow balancing method on the YouTube channel. That might be helpful for you. Okay. Good luck, y'all.